Hello, Willard Wildcats. You have been thinking about survival, how living things face danger and how they can escape that danger to live another day. We live in our homes and in communities that help keep us safe. But our ancestors have not always had such comfortable homes and safe communities. They had to be ready for animals that wanted to eat them and poisonous foods, venomous spiders and snakes and other dangers. We have been able to keep ourselves safe from these dangers for hundreds and thousands of years because of our nervous system. Our nervous system includes our brain, our spinal cord, our nerves, and our sense organs like our eyes, ears, nose, and taste buds. Our senses get information from the world around us. We see, smell, hear, taste, and feel our surroundings. Our nerves send that information to our brain. Our brain makes decisions, and it thinks about what dangers there might be, and it decides what to do. Our brain then sends signals back to our body, and our body follows the instructions. Let me draw it for you. Okay, so here's your body. Here's your head, your neck, one arm, a foot, another foot. There you go. There is your body. And here is your brain. So, there's your body, there's your brain and your head. Let's say that your hand touches something that's very hot. Okay? So here's something super hot. Well, there are heat receptors in your hand. And those heat receptors, those nerve endings that detect temperature, they detect the dangerous heat and they send a message to your brain through your nerves. So a message goes to your brain. Your brain gets the message and thinks, oh, that's hot. Well, I don't want to get burned. So hand, move away from there. And that message gets sent back down to your hand. The message gets sent back through your nerves from your brain to your hand and your arm, and the muscles in your hand and arm get the message to let go, and maybe a message also goes to the muscles in your feet to move away, and so you do. Now that's a lot of back and forth. You touch something hot, a message goes up to your brain thinks about it, decides what to do, the message goes back out. That is a lot of back and forth, but it happens very quickly. The length of time it takes for your senses to send the message to your brain and for your brain to send the message back to your body about what to do, that is called your reaction time. That is your reaction time, and you can measure your reaction time. You do not spend time consciously thinking about whether or not you're going to move your hand away from that hot object. You just do it. You do not have to spend time actively thinking about a lot of what your brain does. When that signal from the hot object goes to your brain, that signal is sent to the sensory receptors in your brain. But if the object is dangerously hot, the signal might trigger a response in your spinal cord that tells you to move away even faster. The signal does not even have to take the extra time to make it all the way up to your brain. This type of fast response that happens in your spinal cord, that is called a reflex. Our reflexes are automatic. They are super fast, and we have no control over them. Today, I do not want to put you in any danger. I do not want to test your reflexes. I want you to test your reaction time. the time it takes for a signal to go all the way to your brain and back. You can measure your own reaction time with a partner and a few simple tools. You will need a ruler that measures in centimeters, a person to help you, a piece of paper, and something to write with. Your partner is going to hold the ruler like this above your hand. They are going to drop it at some point without giving you any warning. Once you see it falling, you need to grab it. Because it's a ruler, we can see exactly how far it fell before I caught it. For example, here it fell 19 centimeters before I caught it. Because we will be measuring, there are a few things we need to think about. First, does it matter which way your partner holds the ruler? This way or this way? Does it matter? It does matter. When you measure, you start from the zero end of a ruler. So your partner needs to hold the ruler with the zero end of the centimeter side. That zero end is going to be right closest to your hand. It's going to be right above your hand. Next, does it matter if they hold the ruler close to or farther away from your hand? Does that matter? Well, it does matter. The zero end of the ruler needs to be right even with the top of your hand. Finally, does it matter how you hold your hand? Will it work the same if you hold your fingers like this or like this? Again, it does matter. If your fingers are too close to the ruler, sometimes when your partner lets go, it'll bounce off your hand, and that won't be a good measurement. Here's the best way to hold your hand. Pretend you're holding an invisible can of vegetables. Hold your hand like that big around. There's plenty of room for the ruler to fall without bumping into you, but it's still, your fingers are still close enough to the ruler that you'll be able to catch it very quickly. Now, the trick is to keep your hand like this while you wait for your partner to drop it. Sometimes your body gets very tense waiting for that ruler to drop, but you can do it. Now, do you have everything you need? Are you ready to start? Okay, great. On your piece of paper, write down the numbers 1 to 5 like this, like you're making a list. Like that. Write down the numbers 1 to 5. You're going to take 5 measurements. You're going to do this thing 5 times, and every time you do it, you're going to write down the distance on your piece of paper. Ready? Pause the video and begin. Get your measurements. All right, I have my 5 measurements. Do you have yours? Okay, now we're going to do something mathematical. We are going to calculate what's called the average of our measurements. That means we're going to calculate the middle value. The way you calculate an average is you add together all of the measurements and then divide by the number of measurements that you took. So first, we need to add together all the measurements. So 10, 14, 18, 22, 21. And add all those together. So 8 plus 4, 8, 9, 10, 11, 12, 13, 14, 15, 5, and carry the 1, 1, 2, 3, 4, 5, 6, 7, 8, 85. So you add those all together and you get 85. Now, that's a pretty big number, 85 centimeters, right? 10 centimeters, 14 centimeters, 18 centimeters, 22 centimeters, 21 centimeters, add them all together, you get 85 centimeters. Now that's a pretty big measurement, but to calculate the average, we divide this number by the number of measurements we took. Well, we took 1, 2, 3, 4, 5 measurements. So we're going to take that and divide it by 5. Five goes into 8 one time. 8 minus 5 is 3. Bring down the 5. 5 times 7 is 35. So our average is 17 centimeters. It's like the middle number. So the average is 17 centimeters. And if you look, that sort of makes sense. It's not the biggest of these numbers. It's not the smallest. It's somewhere in the middle. I never actually had a measurement of 17 centimeters, but that does not mean that 17 cannot be my average. So from this number, from your average, from this, you can calculate your reaction time. Now, just a heads up, this could have been a much more difficult number if it had been something like, I don't know, 87. What if, when I added them all together, I got 87 centimeters, and I had to divide that number by 5? Well, 5 goes into 88 once, and then that's 5. 8 minus 5 is 3. Bring down the 7. And that's also still 7. 5 times 7 is 35. That's a remainder of 2. Well, you know what? Take your nearest whole number. If you have a remainder, that's fine, but the remainder isn't going to matter for the average. So even if this was 17 with a remainder of, 7 minus 5 is 2, with a remainder of 2, we would have just used the whole number and ignored the remainder. We would have still had an average of 17. So from this number, from your average, you can calculate your reaction time. The time it took between when your partner dropped the ruler and when your brain got the message and sent the message back to your hand to grab it and catch it. The thing is, objects fall at a very predictable rate. So by knowing how far it fell, we can calculate how much time passed before you caught it. Now the trick is the math to do that is pretty complicated for 4th grade. So instead of asking you to do the math, I made a table that you can look at to figure out what your reaction time is. Now, if you look at this table, you will notice that it does not list every possible distance on the ruler. If your average distance is 20 centimeters, well, that's easy. Your reaction time is listed right here, 0.20 seconds. That is 20 hundredths of a second. But what if your distance is not listed here, like mine? My average is 17 centimeters. Well, 17 is between 15 and 20, and we have the numbers for 15 and 20. So my reaction time is going to be between the 15 centimeter and the 20 centimeter times. So my reaction time will be between 0.18 and 0.20 seconds. So my reaction time will be between 18 hundredths of a second and 20 hundredths of a second. So that's my reaction time between those two numbers. That's very, very fast. So in just like 0.19 seconds, that's how long it took for the message that the ruler was falling to go from my eyes to my brain and then back out to my hands so that I could catch the ruler. So I'm curious, what was your reaction time? Were you faster than me, slower than me, or the same as me? It's different for everyone. I wonder how we compare. That also makes me wonder, I'm older than all of you. Do you think reaction time changes as you get older? Or what if we practiced? What if we practiced catching rulers a lot? What if you practiced every day for a week? Do you think you could improve your reaction time with practice? What do you think? And I know that at different times during the day, especially when I'm feeling tired at the end of the day, I do not feel very quick. I wonder, is my reaction time different at different times of the day? What do you think? I hope that you are curious and that you do some experiments. If you do, please let me know what you discover. I'll see you next time.